Good day, my dear students. Once again, I would like to welcome you to the class of Food Biochemistry, BCH 308. The topic of today's lecture is food analysis and rancidity. Food analysis and rancidity. I am yours faithful, Professor H.O.T. Yahweh. In the past lecture, we dealt with a topic wherein we talked about food biochemistry. What is food biochemistry? I remember stating that it's a study of the chemical processes in food systems which focus on food composition, transformation during processing and storage, and it covers areas of carbohydrates, protein, lipids, vitamins, minerals, water, enzymes, and bioactive compound. Of course, the study of food biochemistry have some implications. That is, it explains the quality and safety of food, nutritional value. It helps us to understand the concept of flavor, color, texture. All these support food processing and preservation, as well as analytical techniques. The analytical techniques help us to ascertain or establish the quality and food safety, or the safety of the food item, as well as the nutritional value. I also referred you to the biochemical reaction in food, which includes, I beg your pardon, enzymatic browning, lipid oxidation, protein denaturation. All these are meant to affect the shelf life of the food, taste, appearance. So, in today's class, what are we going to talk about? Like I told you, the topic, food analysis and rancidity. We are going to look at it in two sections. Section 1 will be food analysis method. Now, what is food analysis method? Or what are the methods employed in food analysis? We have two major approaches when it comes to food analysis. One, we have the physical method and we have the chemical method. These two methods complement each other. The physical method ensures that the food material you are testing does not undergo any chemical change. It is usually very fast, and because it does not involve any chemical change, it is referred to as non-destructive. Examples of physical method include spectroscopy, which are diverse. It could be ultraviolet, infrared, or near infrared. It also includes microscopy, texture analysis, viscosity measurements, and moisture determination. Now let's look at spectroscopy. It's a device that uses light interaction to measure color, moisture, pigments. Of course, this is especially popular with near infrared devices. Microscopy and texture analysis. Microscopy involves structure and contaminant assay. Texture involves firmness and elasticity. These are important for processed food. Now let's look at chemical methods. These essentially involve chemical reactions in food analysis. Chemical method is also used for contaminant detection. When we talk of contaminants, it could be accidental contaminant or deliberate contaminant by way of adulteration. Examples of chemical methods include proximate analysis. Proximate analysis, when completed, normally sum up to 100%. Titration, spectrophotometry, which is different from spectroscopy, although they both involve the use of light, chromatography, and enzymatic assays. The proximate analysis determines factors like protein, fat, carbohydrates, ash, moisture, and these form the basis of nutritional labeling. When you take any food sample in market that is processed, you look at the packaging, you will see the list of the approximate analysis. It is always provided. The second section we are considering is rancidity in food. What is rancidity? Rancidity is simply deterioration of fats and oils. And when this happens, it leads to bad smell, off taste, and reduced quality of food. There are two types of rancidity, which are oxidative rancidity and hydrolytic rancidity. Oxidative rancidity is the reaction of food material with oxygen that eventually affects the unsaturated fats. When this happens, it produces this reaction with oxygen produces aldehyde and ketones. These are the causes of the bad odor that occur in food. Factors affecting oxidation include heat, light, oxygen, and mineral elements like iron and copper. Auto-oxidation. This occurs spontaneously to produce free radical processes, which include initiation, propagation, termination of the reaction that eventually produces peroxides, which affects the state of the food item. Now, antioxidants play a role in all these processes. What do? They prevent food oxidation. And how are they employed? They are employed by way of addition as food additives. The intention is not to add any nutrients to the food, but rather to prevent oxidation. Examples of these include our popular vitamin E, tocopherol, the BHT, the butyl hydroxyanisole, and um, butyl hydroxytoluene, that is BHC and BHA. BHA is butyl hydroxytoluene, while BHA is butyl hydroxyanisole. When used appropriately, these agents help to improve the shelf life of the products. Now, the second type, hydrolytic rancidity. This is caused by water and enzymes. This reaction breaks triglycerides into free fatty or to produce free fatty acid. It is common in the fatty food like butter and dairy products. Let's look at factors accelerating rancidity. Factors accelerating rancidity. They are oxygen, light, high temperature, microorganisms, and enzymes. When these are present in food and are not properly um, protected or preserved or prevented, then rancidity is setting to occur. Loss effect of rancidity. Rancidity can produce loss of nutrients, poor taste, and health risk due to toxic compound formation. How do we now detect rancidity? We can detect rancidity by sensory evaluation, by way of smell and taste, analytical analysis, through estimation of peroxide value and acid value. What has been our talk so far? We have mentioned that food biochemistry studies biochemical processes in food. We also mentioned that food analysis uses chemical and physical methods. We also understood that rancidity affects food quality and that prevention is essential for food safety. This is a set of study questions for you to tease yourself and appraise your understanding of the course. Take time to work it out. This is the end of the lecture. Thank you very much and stay blessed. Have a nice day.